Okay, just some complex numbers questions. Alright, so if we look at the first part, so we've got z equals 1 plus cos 2 theta plus I sine 2 theta. Now, the first thing that I would be doing here is this 1 minus cos 2 theta. So you know that sine squared theta equals a half 1 minus cos 2 theta. So it's handy to know that 1 minus cos 2 theta equals 2 sine squared theta. You can do the same thing if you see a 1 plus cos 2 theta. That will equal 2 cos squared theta, because we know a half, cos squared theta is a half 1 plus cos 2 theta. So the other thing, this sine 2 theta equals 2 sine theta cos theta. Now the reason that I'm doing this, by doing this, what I'm actually doing is I'm going to put this into mod arg form. And when I put it into mod arg form, then there's a whole lot of other stuff that I can actually do with it. So it'll be 1 minus cos 2 theta plus I sine 2 theta. If you look at that, then that would be 2 sine squared theta plus I 2 sine theta cos theta. So there's a common factor here of 2 sine theta, but when you do that, you get sine theta plus I cos theta, and that isn't in mod arg form. So what I'm now going to do is take an I out, because if I take an I out, that means that would be minus I sine theta, and then it'll be plus cos theta. Now, why was that minus? That was minus is because if you did this I times minus I, you end up with minus I squared, which is minus 1 times minus 1, which is 1. Okay, so that just means then you've got 2I sine theta, and then I'm just going to switch this around, so you've got cos theta minus I sine theta. Now, what are we actually trying to do with this? We want to find mod z. So if this was equal to z, 2I sine theta cos theta minus I sine theta, then the modulus of z is the same as the modulus of this here. And there's actually two complex numbers here. So there's this one here and this one here. So the modulus of that would be the modulus of 2I sine theta, and the modulus of this one, cos theta minus I sine theta. Now the modulus of the first one, so this one here, is the square root of 2 squared sine squared theta plus 0 squared, because it's like 0 plus 2I sine theta. So, and then this one, the modulus of this one will just be 1, because it's cos squared plus minus sine theta squared. So it's just going to be 4 sine theta times 1, so it's just going to be 4 sine theta. Okay, now when you want the argument of z, that would be the argument of 2I sine theta cos theta minus I sine theta. So there are two complex numbers there, and they're multiplying. So it's the argument of 2I sine theta plus, because we're timesing, the argument of cos theta plus I sine theta. So the argument of this one here, because it's just like an I, that means that it is on the vertical axis, which is the imaginary axis. So the argument of anything on the imaginary axis, like along here, because sine theta would be positive, it would be on the positive half, will be pi on 2 or 90. Now this in here, sorry, that had a minus there. That's the argument of cos, now it's going to be minus theta plus I sine minus theta if I put it into the proper form. So the argument of this one is that angle, and that angle is minus theta. Now I put that back in because that was minus sine, so when I put that back in it's minus theta, and cos of minus theta and sine of minus theta is minus sine theta. Okay, and that's proven.